from the 2019 AP exam, and it's about Taylor polynomials. So part A says, well, we're given a function that has derivatives of all orders for all real numbers x. A portion of the graph is given above, along with the line tangent to the curve at x equals 0 and selected values. Okay, so part A wants you to write the third degree Taylor polynomial. So let's remember what a third degree Taylor polynomial looks like. This one is centered at 0, so that would be f of 0 plus f prime at 0. Then you have the second derivative at 0, x squared divided by 2 factorial. And it wanted third degree, so we're going to go one further. X cubed over 3 factorial. So now we have to get our information from the graph. So looking at the parabola, we can see that f of 0 is equal to 3. The next thing we notice is that the slope of this is -2, so f prime at 0 is -2. And then after that, we're going to our table. So let's see, our second derivative is 3 over 2 factorial, which is the same thing as 2. And then lastly, the third derivative is right here. So minus 23 halves x cubed over 3 factorial. So there's our P3 Taylor polynomial. Part B, write the first 3 non-zero terms of the Maclaurin series for e to the x. Since it asked me to do this separately, I'm going to go ahead and write that out. So e to the x is 1 plus x squared over 2 factorial, and that would be 3 non-zero terms. What they want us to do is to multiply f of x, which we just found in part A, by e to the x, and they want us to give them a second degree Taylor polynomial. So I'm going to go down here. So let's see, my polynomial first was 3 minus 2x plus 3x squared over 2, and it keeps going. Then we're going to multiply it by e to the x. And now we only want degree 2, so we only have to multiply a finite amount of terms. So the first thing I'm going to look for, is there any way I could get a constant by multiplying these 2 terms? And I can get a constant by multiplying 3 by 1. And I believe that's the only way we can get a constant. The next place I look for is we're going to look for how many ways we can get a linear. So a linear, which would be just x to the first power. So if I take this 3 and multiply it over here to this x, I'm going to have 3x. So I'm just going to write it as 3 and put the x right out here. If I take this term and multiply it by this term, I'm going to get -2x. So far our polynomial is 3 plus 1x. You don't need to simplify that. And the next thing it wants us to find is the second degree. So here we have plus. Now we're going to get anything with the x squareds. So if I take my first 3 and multiply it by over here, I would get 3 halves x squared. Then we're going to go to this one and multiply it by here, so minus 2 x squared. And then lastly, we're going to multiply this one by this one, which would be, again, 3 halves x squared. You don't need to simplify this, but if you do, it would be 3 plus x. 3 halves plus 3 halves is 6 halves minus 4 halves, which would also be 1, so plus x squared. So that's part B. Part C says, let h be a function defined by this. Use the Taylor polynomial found in part A to find approximation for h of 1. So all we're going to have to do is integrate the polynomial that we had in part A. Notice this is a definite integral, so we don't need a plus C. Okay, so let me grab a new page. So part D said, is known that the Maclaurin series for H converges for all H of X for all real numbers. It is also known that the individual terms of the series alternate in sign and decrease in absolute value to 0. What this is saying is that it's a convergent alternating series. Use the alternating series error bound to show the approximation found in part C differs by H of 1 by at most 0.45. Now, remember, the polynomial from part C came from integrating the polynomial in part A. We used all of these terms to do the approximate. For the alternating series, the first omitted term is the error. So I need to go back up here and build my next term. So my next term would have been 54x to the 4th over 4 factorial. That's our term for f. And the rest of the polynomial is in front of it. If I want to get to h, that means I have to integrate it. So 54x to the 5th, 5 times 4 factorial, which is the same thing as 5 factorial. So my error is going to have to do with this value. 54x to the 5th. Part A is worth 2 points, 1 for the first 2 terms, 1 for the second 2 terms. Part B is worth 2 points also. You get 1 point for writing e to the x, and you get 1 point for finding the polynomial after you multiply. You can leave it unsimplified. Part C, you get 1 point for the inner. So for part C, going back to that, we know that we're going to take, we know that h of x is equal to the integral of 0 to x of f of t dt. So for us, h of x is going to be the integral of f, and f was given to be, or found to be, 3 minus 2x. So 3 minus 2x plus 3 halves x squared minus 23/12 x cubed. Now, they told us to use the polynomial we made in part A. So that means we're going to use the entire polynomial. Sometimes they will say use the first 3 terms, use the first 2 terms. They said to use the polynomial found in part A. So I'm going to have to integrate this because this is our polynomial for f of x. So we're going to integrate that to get to h of x. So 3x minus x squared plus x cubed over 2 minus 23x to the 4th over 4 times 12 factorial over 4 times 12. And then we were going to use this to approximate h of 1. So h of 1 would then be just plugging in 1 everywhere. And again, this is not a calculator problem, so just leave it alone. Part D. Let me go back and see what it asked. So D, for an alternating series, for a convergent alternating series, the error is less than the first omitted term. So we had that our term was 5th over 5 factorial. And remember, we were plugging in at 1, so our error is going to be less than 54 times 1 to the 5th divided by 5 factorial. So do we actually believe that's less than 0.45? I think absolutely, because we have 54 over 120, and that's definitely less than 0.45. So how was this scored? And you get 1 point for the evaluation. Part D, you have to have known that you used the fourth term, so you have to show that you found fourth term, which I would put this all in the same piece of paper if I didn't have to keep flipping back and forth. So found fourth term, you get a point for that. Integrated it. Actually, found fourth term, that's all of the integrating. The next one uses the first omitted term and then the error bound. So you get 1 for right here, 1 for showing this work, part of it was up there, and 1 for showing that that's true.